Section 7.3 is solving quadratic equations by the square root method. Back in section 6.6, we learned how to solve quadratic equations. So for example, we might have x squared plus 2x equals 24. And we would recognize immediately that that's a quadratic equation. How do we recognize immediately that that's a quadratic equation?
Squared.
It's got an x squared. And once again, how do we solve quadratic equations? Set it equal to 0. X squared plus 2x minus 24 equals 0. And then what do? We have to factor it. We have to find the multiples. Can you factor x squared plus 2x minus 24? Six and 4. So I think it has to be x plus 6 and x minus 4. So that gives us two answers. X plus 6 equals 0, or x minus 4 equals 0. X is negative 6, or x is 4. Well, that looks wonderful, I suppose, until I change the problem slightly. What if I give you x squared plus 3x equals 24? It didn't change very much, did I? What did I change? I changed one number. All I did is change the 2 to a 3. We start the same way. X squared plus 3x. Oops. X squared plus 3x minus 24 equals 0. But then we have a problem. What's the problem? You can try as hard as you want. You cannot factor that polynomial. X squared plus 3x minus 4 does not factor. Simply doesn't. You try all the possibilities, it doesn't work. So what does that mean? Okay, it means this polynomial is prime. That's true. But does it mean that this equation doesn't have any answers? No, I think this equation still has answers. Let's draw a graph of it. So if I were to grab my calculator and type in x squared plus 3x minus 24, and draw a graph, you can see we're getting a parabola. We don't quite see the whole parabola. We can change our window if we needed to, but you get a parabola, comes down, comes back up. And we knew it should have been a parabola. We knew that from sections 7.1 and 7.2. Does this equation have answers? Is there some place where that equation equals 0? Yeah, and where does that happen on the graph? Yeah, but I'm really asking you to find where does an equation equal 0? I'm really asking you to find where does it cross the x-axis? Does this graph cross the x-axis? Absolutely, it crosses twice, doesn't it? So does this equation have answers? Yes. The problem is we can't factor it. So what does that mean? All right, one way we could solve it is certainly by using our calculator. Okay? So how do I use my calculator to solve an equation? Okay, I already typed it into y equals. How do I use my calculator to solve an equation? I go into the calculate menu. The calculate menu is on the trace button. See where it says calculate up there? So I go second, calculate. And what do I want to find? I want to find a 0. I want to find where that equation equals 0. So I hit enter. All right, now it asks me for some interesting things. Let's say I'm trying to find this spot over here. It's asking left bound question mark. What it wants is it wants me to be somewhere on the graph left of this spot right here. So I'm just going to use my right arrow to move a little bit so I can see the cursor. There it is. So that's somewhere left of that spot I want to find. So I hit enter. And now it asks me for a right bound. So now I need to be somewhere over here, somewhere to the right of that point. So I move over and I hit enter. And then it asks me for a guess. So it tells me the answer is 3.62344754. So there's one of the answers. How would I find the other answer? Do the same thing, except I'd have to use this point over here. I'd have to go left of this point, right of this point, find the answer. All right, so that equation has answers. And we can find the answers using the calculator, but at this point we cannot find the answer by hand. We have no technique for doing that because the equation doesn't factor. At this point, the only kind of quadratic equations we can solve by hand are equations that factor. What we're going to do over the next 3 sections, it's going to take us 3 sections to get it all done, is learn ways to solve quadratic equations by hand. Quadratic equations that don't factor. There are multiple techniques. The one we're going to learn today is called the square root method. So let's start with an equation that we can solve by factoring. There's one we can solve by factoring. X squared equals 9. How do you solve that equation? What's that? Well, I don't know. I want to solve it by the way we've always solved quadratic equations. How do we solve quadratic equations? We minus 9 on both sides. Get 0 on one side, and then what do? We factor. How does x squared minus 9 factor? X minus 3x plus 3. So we have x minus 3 equals 0. X plus 3 equals 0. And how many answers do we get? 3. Or 2. 3. We get 2 answers. I was writing the number 3 as I was writing x equals 3. We get 2 answers. But that's not the square root method, is it? What method was that? That was the solving by factoring. All right, so here's what the square root method is going to look like. Notice that to go from 9 to 3, what's the relationship between 9 and 3? Square root. All right, so what we'll do, if we have something like x squared equals 9, we're going to do the square root on both sides. Why do we do square root? What happens on the left-hand side? What happens to a square and then a square root? They're inverses. They cancel each other. So what do I have on the left? Just have x. What do I have on the right? All right, well, what I have on the right is incorrect. What I should have is, I know what the answers have to be, right? How many answers should I get? I should get 2. I should get a positive 3 and a negative 3. If I write that symbol right there, that symbol means the number 3. I only have 1 answer. How many answers should we have? 2. So the moral of the story is, anytime you do a square root, there are 2 square roots. The square root of 9, if I ask you what's the square root of 9, most people will tell me the answer is 3. Some people will tell me correctly the answer is 3 or negative 3. The number 9 has 2 square roots. And what you need to remember is, with quadratic equations, how many answers do you get? 2. You should almost always get 2 answers. Once in a great while, you'll get 1. We saw that. All right, so now let's try one that won't factor. What if I gave you x squared minus 8 equals 0? Can you factor x squared minus 8? I don't think so. How come you cannot factor x squared minus 8? 8 isn't a square, isn't it? Is it? In order to factor, we need square minus square. 8 is not a square. But we can still solve it now. How would we solve this now? If you can't factor, what are you going to do? Square root it. But before we square root it, what do we need to do? We need to add the 8. So this is different. With the square root method, it doesn't do you good to have 0 on one side. When you're doing the square root method, you want the thing with the square to be on one side.
So we're not adding it.
But we added 8 to both sides. That's all. 0 plus 8 gives us the 8. And then we do square roots. And when we do square roots, we always need to remember there are 2 of them. There's a positive square root and a negative square root. So the answers are, and we write our answer this way, x equals plus and minus the square root of 8. And that looks like one answer to a lot of people, but there's really 2 answers there. What are the 2 answers? One of them's the square root of 8, and one of them's negative square root of 8, and you were giving me decimal approximations for square root of 8. That's fine. Questions on that?
So
That's it? For that problem.
So are we going to add a decimal?
I would be fine if you wanted to type that into your calculator. You could tell me x is plus or minus 2.828. That would be fine. Usually we don't. Usually we just leave our answer with square roots. Leaving it with square roots are fine. All right, how about this one? How about x plus 3, whole thing squared, minus 16 equals 0. Any thoughts on how you could solve that equation? Okay. So what do you mean by do the parentheses? Foil it out? Okay. So if I were to take the parentheses and foil it out, I would have x squared plus 6x plus 9 minus 16 equals 0. And then I think I would go ahead and combine my like terms. What's 9 minus 16? Negative 7. X squared plus 6x minus 7 equals 0. Can you factor x squared plus 6x minus 7? I think so. Positive 7 and negative 1. I think will work. That'll give you a negative 7 on the end and a 6 in the middle. So I get 2 answers. What are my 2 answers? Well, I would have x plus 7 equals 0, x minus 1 equals 0. So I would get 2 answers. X equals negative 7, x equals 1. That was such a fun problem, I'm going to do it again. I enjoyed that one so much. I'm going to do it differently. That's correct. Anybody have thoughts on a different way that I could answer that problem? I could add the 16. All right, so I have x plus 3, whole thing squared, equals 16. And then what? Square root both sides. Why do I square root both sides? On the left-hand side, I have something that has a variable in it, x, and it's a perfect square. So what happens when I have a perfect square and I do a square root? They cancel out. So I end up with x plus 3 equals, what's the square root of 16? Plus and minus 4. And then I subtract the 3. So I'm going to write x equals negative 3 plus and minus 4. Which is a perfectly correct answer, but normally we would simplify. So normally we would write x equals, what's negative 3 plus 4? 1. And then we would have x equals, what's negative 3 minus 4? Negative 7. The good news is, we got exactly the same answer both times. So why did I do it both ways? Which way was easier? The second way? I don't know that the second way was actually easier. I don't know that there was much difference in the two ways. We're very used to the first way, that's correct. However, what I did when I wrote this problem, I wrote this problem down to make sure that when we did this foiling and we combined our like terms, I made sure that that was going to factor. The reality is that doesn't always happen. And again, I could change the problem very slightly. I could write x plus 3 squared minus 15 equals 0. And you could try it. You could FOIL this out, combine your like terms, and then you would be stuck. You would find that that does not factor. It simply doesn't, no matter how hard you try. In general, doing FOIL is a bad thing as far as solving equations goes. You really don't want to FOIL. You want to avoid foiling as much as possible. Because when you FOIL, you end up with something like this, and then you have to turn around and you have to factor it anyway. Sometimes it will factor, sometimes it won't. What I see on this problem is I see that I have something with a perfect square. So what I want to do is I want to get this piece all by itself. Why would I want to get that piece all by itself? Because it's squared, and if I have this piece by itself, I can get rid of the square. How do I get rid of the square? Square root. So what I would do on this problem is I would never FOIL that out. I would write x plus 3 squared equals 15. And then I would square root both sides. So I would have x plus 3 equals plus and minus square root of 15. Square root of 15 is not a nice number. It's a long, ugly decimal. So I leave my answer just like that. I'm going to leave it with plus and minus square root of 15. I'm not going to do decimals. The only thing I got left to do is I need to get x all by itself. So how do I get x all by itself? Subtract 3. So we would generally write x equals negative 3 plus and minus square root of 15. On the problem on the left, the answers came out to be nice, so I simplified them. On the problem on the right, it's not nice. The square root of 15 is not a nice number, so I leave my answer looking just like that. Questions on that? All right, one more of these. How about 3x minus 2 squared minus 21 equals 0. What I will see a lot of students do on this problem is I'll see them take 3x minus 2 and they'll FOIL it out. And they'll combine their like terms. Is that wrong? It's not wrong. It's long. That's correct. It's harder to do it that way. What you want to notice is that you have a parenthesis with a square. So what do you want to do? Get that all by itself. So you want to get the thing with the square all by itself. So we add 21 to both sides. And how does it help to get the thing with the square all by itself? you can square root it and get rid of the square. And that's kind of the goal for these problems. The goal for these problems is to get rid of the square. So we square root on both sides. 3x minus 2 equals plus and minus the square root of 21. Is the square root of 21 a nice number? No, it's some ugly decimal, isn't it? So I leave my answer just like that. Which tells me that if I'd have started by FOILing this out and combining like terms, my thing wouldn't have factored and I'd have been stuck. Would have been in a bad situation. All right, well, all that's left to do now is we need to get the x all by itself. So what would you do to get the x all by itself? Add the 2. So we would write 3x equals 2 plus and minus square root of 21. And then finally, divide by 3. And when we divide by 3, we need to divide everything by 3. So we would write our answer as x equals 2 plus and minus square root of 21 all over 3. Questions on that?
I know you are your square root of, once you get it by itself, square root of 3x minus 2. Well, why do you just move the 2 and just add it to the answer?
If I take 5 and I square it, and then I square root it, what happens? What's 5 squared? 25, right? What's the square root of 25? 5. So if I have this square and I have this square root, what do they do to each other? They're inverses. They reduce each other. So the only thing left is the number 5 that I started with.
So is there ever going to be a time where it doesn't go like that?
No. Never. And that's the whole idea behind the square root method. The square root method is a technique for getting rid of the square. Okay? Other questions?